The first thing was the weight of the car. I wanted to make the car as light as possible without it being flimsy so the car would go faster as well as farther. So I used things like lighter woods to make the frame, and CDs are also relatively lighter than most wheels, so I use those as opposed to a heavier object. I also wanted to reduce the friction of the car as much as possible in order to increase the distance. I used a lighter wood to reduce air resistance as much as possible because having air resistance would require my car to use more energy and therefore slow it down. So I wanted to get rid of that altogether. I also used balloons on my wheels in order to make the surface friction work to my advantage so the car wouldn't just spin out of control when I launched it. The first major type of friction was between the wheel and the ground. When the wheels would go, the movement of the wheels on the floor creates thermal energy, causing the car to slow down. So, in order to make this friction work to my advantage, I placed rubber balloons on the outside rims of the wheels, which creates traction along the floor and allows the car to go farther by having the car push itself along the floor instead of it having to spin out of control. There was also a reduction of friction in the axles of my car. I used pieces of an ink cartridge of a pen to create the axle. To do this, I cut off the end of the pen and put it on the tip of the pen. So when the wheel moved, the pen made a circular motion inside of the pen cartridge, causing the friction to be reduced and allowing the car to travel faster. Newton's first law of motion states that objects at rest tend to stay at rest, and objects in motion tend to stay in motion unless acted on by an external force. There are several types of forces, but the main one we focus on for this car is friction. There are several types of friction in this instance, including air resistance, friction from the floor, and friction from the moving parts. So the goal from the mousetrap is to reduce as much friction as possible to get the farthest distance. Newton's second law states that force is mass times acceleration. For our mousetrap car, that would mean that the lighter the device is, the further it should go with the same amount of force. This proves that we should do everything we can in order to create the lightest vehicle possible. Newton's third law states that for every action there is an equal and opposite reaction. This concept is applied to the mousetrap car since the spring from the mousetrap has a lot of built up tension in the opposite direction that the car moves. So as the tension is released, the car moves forward. Loading the spring of a mousetrap stores potential energy, but when that spring is released, the potential energy gets transferred into kinetic energy, but the total amount of energy throughout the entire process will always be the same. In a perfect world, the car would go on forever without stopping, but in our world, there's friction, and in order to overcome that friction, the car must do work. Friction converts the energy of moving objects into heat, and that will eventually cause a moving object to stop altogether. And the faster a mousetrap vehicle moves, the harder it will have to work to push more air out of the way, and that takes energy away from the system.